All right, we are now starting chapter 1. We're no longer in the prerequisite chapter, which is good. We're going to talk today about linear equations in one variable. What is a linear equation? What does that mean? Line. What is the exponent of x or y or whatever the letter is if you have a linear equation? 1. Good. If you were to graph it, it would make a line. So our solving steps, you guys I know are familiar with, but you're going to isolate the variable. That means you get it by itself. There's sometimes special cases we'll talk about. If the left-hand side and the right-hand side of the equal signs are equal, your answer is all real numbers. What that means is you might work something out where your variables cancel out and you get like 12 equals 12. What that means is any number in the world that you plug in for x will satisfy both sides of the equation. So your answer would be all real numbers. All right, that might be a case in web assignments, so make sure you guys pay attention to that. And then if the variable cancels out and what's left is a false statement, your answer is no solution, meaning your variables cancel out and you come out with something like -1 equals 7. Does -1 ever equal 7? No, that's why it would be no solution. All right, so those are the two cases where you would have either all real numbers or no solution. So let's just get into solving. All right, again, I'm going to highlight a couple things at the beginning and then we're going to get moving. But remember, guys, your order of operations, PEMDAS, right? In order to solve equations, you do that backwards. It's SADMEP. You first isolate the variable, and then you're going to work backwards. You get undo, you're going to get rid of subtraction, addition, then division, multiplication, then exponents in parentheses. We work backwards. So if I'm trying, in number 1, I'm trying to isolate x. So what's the first thing I'm going to do?
You can do...
I'm going to add 6. Good. So add 6 to both sides. So 3x equals 6. And then what?
Divide.
Perfect. Divide both sides by 3. And you come out with x equals what? 2. Now, all of these, guys, you're going to come out with x equals y equals whatever, a number. What can you do with that? You can take your answer and plug it back in. 3 times 2 is 6. 6 minus 6 is 0. You're good to go. Now, we're going to talk in later sections about something called extraneous solutions. That means you come out with an x, but when you plug it in, it doesn't make your solution true. So we'll talk about that later. All right, how is 2 a little bit different? There's variables where? On both sides. Okay, it's personal preference. I personally like letters on one side, numbers on the other. I like the letters on the left, numbers on the right. So I am going to subtract 3x from both sides. And then I'm going to subtract 4 from both sides. Do you guys agree with me on that? Okay, so 5x minus 3x is 2x. -8 and a -4 is -12. Then we divide both sides by 2. And x equals what? -6. And again, you can plug -6 in for both of your x's and check your solution. So number 3. What kind of a 7 is in front? That's positive, right? So to get it to move to the other side, we're going to subtract 7 from both sides. I'm left with a -x, guys. That negative didn't go anywhere. So 19 minus 7 is 12. And then how do I make my variable positive? We're going to divide by a -1. Good. So when I divide by -1, I get x equals -12. And again, plug back in. So if I plug in, hold on a sec, -12, what's 7 minus a negative? It's going to be plus. 7 plus 12 is 19. Yes, sir?
Can you just multiply that?
Yeah. Yep, same thing. All right, isolate your variable. What's the first thing we're going to do? Subtract 2. Perfect. 7x equals 21. Divide by 7. X equals 3. Good. Again, plug back in. 7 times 3 is 21 plus 2, 23. Number 5, letters on one side, numbers on the other. So I'm going to add 2x to both sides. And then I'm going to subtract 3 from both sides. So I have 5 plus 2 is 7x equals 6 minus 3 is 3. And then I divide both sides by 7. And I get x equals what? 3 over 7. Am I allowed to get a fraction? Yeah. That's okay. Can you guys still check with a fraction? Yeah. Is it as easy? No, but you can do it. All right, number 6. How do I isolate my x? Subtract 7. Perfect. So I have negative 2x equals 8. Divide both sides by a negative 2. And x equals negative 4. Perfect. Is it really that big of a deal, guys, if you forget a negative sign? Yeah, super big. We have to be diligent. We have to pay attention. All right, let's keep moving here. Again, variables on one side, numbers on the other. So I'm going to subtract 5x from both sides. God bless. And then I'm going to add 9. Do you guys agree with that? Okay, so 7 minus 5 is going to give me 2x equals 9 plus 7 is 16. Divide both sides by 2 and x equals 8. Good. Good job, good job, good job. How is 8 a little different? Parentheses. What do I need to do first? Yes, I have to distribute. Before you guys, you have to get each side of the equal sign simplified as much as possible before you start moving stuff around. So this 6 out in front means I have to distribute here and here. Do you guys agree this becomes 6x minus 6? Then plus 4 equals, if I distribute here, I have 21x plus 3. Can I combine anything else on either side? Negative 6 and 4. So I have 6, what? X. What's negative 6 plus 4? Minus 2. Negative 2. Good. Now I can start moving numbers to one side, letters to the other. Some of you like only variables to be positive. That's fine. I like to move letters to the left-hand side. So I'm going to subtract 21x. And I'm going to add 2. Are you guys okay with that? What's 6 minus 21? Negative 15x equals positive 5. Agreed? Now I divide both sides by a negative 15. Guys, is my answer here negative 3? What is my answer here? Negative 1/3, all right? Very simple mistakes you guys might make by going, oh yeah, 15 divided by 3 is 3. Totally agree with that. But 5 divided by 15 is 1/3. So just make sure you're paying attention. All right, again, look at number 9. What do we do with the 4? We're going to distribute. Good. So I have 4x plus 8, and then I still have the minus 12 equals. We're going to distribute here. So I have 5x minus 30. Good. We can still combine like terms on the left-hand side. So I'm going to have 8 minus 12 is going to be 4x minus 4 equals 5x minus 30. And again, some of you want to move the 4x to the right side. That's fine. I like to have letters on the left, numbers on the right. So I'm going to subtract 5x from both sides. And I'm going to add 4. So my 4's canceled there. My 5x is canceled there. What is 4 minus 5x? Negative 1x. And then negative 30 plus 4. Negative 26. Do I leave my answer like that? We're going to divide or multiply both sides by negative 1. So x equals 26. Very good job. Questions? All right, we're going to get a little more involved in some of the problems. And again, there's going to be personal preference. You guys are going to like to do something some ways. You guys are different. You think differently. That's okay. If you see something that you like to solve a different way and you get the same answer, I'm fine with that. Excuse me. But here, let's multiply. Let's distribute my 3. So 3 times 2 is going to give me 6x minus 12. Agreed? Equals 7. What is in front of that parenthesis that's after that minus sign? What is that? It's a negative 1. I need to distribute that negative 1. So this becomes minus x minus 5. Everybody see that? So on the left-hand side, I'm going to just keep my 6x minus 12. And on the right-hand side, what is 7 minus 5? 2. I have a positive 7, right, and a negative 5. Do you guys agree? So I could write this as 2 minus x. What's another way I could write that? Negative x what? Plus 2. Either way, it's fine. Either way is fine. So now we're going to move letters to one side, numbers to the other. So I'm going to add x to... All right, so here we're going to add x to both sides, yes? And add 12. If you see that I made a mistake, tell me. So 6x and 1x is 7x. What's 12 plus 2? 14. Divide both sides by 7. X equals what? 2. Here's a good thing, though. All right? So we're going through, and so say you make a silly mistake like that, right? How could you have caught that mistake? If you didn't realize you made it, and before you turned your test in, what could you do to make sure that you didn't make any silly mistakes? Plug it back in, guys. Check. Very easily, we make silly mistakes. We all do. It's going to happen. But you guys can do some things to alleviate that from happening. So just take your time. Check. No biggie. All right, so let's distribute. What's 4 times negative 2? So negative 8x. Good. 4 times 1 is? Good. Equals 6 what? Minus 2x plus 4. We're distributing that negative sign. Very good. So let's combine. Keep my negative 8x plus 4 over here. Equals, what's 6 plus 4? 10. So 10 minus 2x, another way we could write it is negative 2x what? Plus 10, okay, either way. So I'm going to add 2x to both sides, and I'm going to subtract 4. Yeah? Okay, so negative 8x and 2x is equals 6. Divide both sides by negative 6, and x equals negative 1. Good. All right, now we get to a problem like this. Now again, there's a bunch of different ways you guys can do this. There's some ways I like to do it. There's going to be some ways you like to do it. But do you understand that we have fractions now? You guys see that? What does that 1/5 in front mean? You have to distribute it, all right? So I'm going to go ahead and distribute this. I'm going to say 1/5 times 2x and 1/5 times 5. When I multiply 1/5 and 2x, I get what? 2x over 5, good. And then what's 1/5 times 5? 1. And then I have x plus 2 over 3. You guys agree? Okay. So now, what can we do here? Well, if we're going to add fractions, what do we have to have? A common denominator. What's a common denominator, guys, between... Now, I'm looking at this, I think, a little differently than some of you are, which is fine, which is totally fine. I'm going to show you different ways. I see, if I'm just going to work on just this side of my equal sign, what's a common denominator between 5 and 1? 5. So if I change this to fifths over here, do you guys agree that this gives me 2x plus 5? If I change this to fifths, I change this to fifths. And then over here I have x plus 2 over 3. Yeah? Now, some of you said 15. So you want to multiply everything by 15 and get rid of the denominator? That's fine too. But does anybody know what we do when we have a fraction equal to a fraction? How can you solve this? You can cross multiply. I can say 5 times x plus 2 equals 3 times 2x plus 5. Now, if you went through, multiplied it by 15, okay, fine, do that. That's fine. It's going to end up with the same thing. That's just how I like to do it. So now what am I going to do? I'm going to take my 5 and do what? Distribute. Good. So you have 5x plus 10 equals what? 6x plus 15. Let's move numbers to the left and letters to the right. Or we're going to move letters to the left and numbers to the right. It doesn't matter. Just make sure your signs are correct. I personally am going to subtract 6x from both sides. And I'm going to subtract 10 from both sides. So what's 5x minus 6x? Negative x equals what? What's 15 minus 10? 5. So what does x equal? Negative 5. Good. Did anybody do that a different way? You can. That's fine. You did? Did you get the same answer? Yes. You're good to go then. Thanks for talking to me. Whoa. Whoa, look at 13. As soon as we see 13, we're like, oh no. Oh no. Richard, what do you see here? What would you do?
I would try to add the left side together.
Okay.
And simplify it.
Okay, get a common denominator. That's fine. What else? Anything else we could do here? Tell me, Paul.
We could multiply each term by 12 to get rid of
Okay, you can multiply each term by 12 to get rid of the denominators. Either way, we'll get the same exact answer. If we go about getting a common denominator on the left-hand side, what would your common denominator be on the left? 6. So you'd have to multiply the first fraction by the numerator by 2. Right? Your second fraction by 3. And on the right, do the same thing. I'm going to do this the way Paul said it, because this is the way some of you said to do the last problem. What about if I multiply the whole equation by 12? Remember, what you do to one side of an equation, you have to do where? To the other. Okay, so
You get 12.
because 3 times 2 would be 6, and then 4 times 3 is 12. Could you make 6 into 12? I was just thinking of the least common denominator between 2, 3, and 4. So what happens in this case? I'll do it both ways so you guys can see. What happens in this case? If I multiply the whole thing by 12, look at my first fraction. Just 12 divided by 3?
Yeah.
Yes. How much? 4. So I'm going to have to multiply this by 4. 2x plus 4. What about 12 divided by 2? 12 divided by 2? 6. So this becomes 6x. What's 12 divided by 4? 3. So this becomes 3x. And then what's 12 divided by 3? So this becomes 4 times 7. Now that they all have the same denominator, you can just cross it off, which would happen. We'll talk about that a little later when we get a common denominator. Let's do it this way. I just want to show you guys. Let's get a common denominator on the left. What are you going to tell me my common denominator is? 6. Okay, so this first fraction, we're going to do it the other way. This first fraction has a 3. What does it need to be a 6? So I'd multiply the top. You guys agree? 2x plus 4. All right. The second fraction has a 2. What would I have to multiply it by to make it a... Okay. So this will become plus 3x. You guys okay with that? Yeah. Okay. So equals... What's my common denominator on this side going to be? Between 4 and 3? 12. Okay. So the first fraction has the 4. What does it need?
3.
What would I multiply 4 by to make it 12? 3. So what you do to the bottom, you do to the top. So this becomes 3x. Minus. My second fraction has the 3. What would I have to multiply it by? 4. So this becomes 4 times. You guys agree? Now, do I have a fraction equal to a fraction? Yes. So let's go ahead and clean this up over here. This becomes 4x plus 8 plus 3x. So it's 7x plus 8 over 6.
Yeah.
And then over here I have 3x minus 28 over 12. Do I have a fraction equal to a fraction?
Yeah.
So what can I do? Cross multiply. So 6 times 3x minus 28 equals 12 times 7x plus 8. Everybody with me?
Yeah.
Okay. So what do I get?
18x.
Mm-hmm.
168.
168. Do we agree?
Yes.
Okay. Equals what? Do we agree? All right. Now what? You want to subtract 84? I agree. So I'm going to move it over here. And then what?
Add 168.
Okay. Now what? Okay. Anybody? What's 18 minus 84? Negative what?
66.
Okay. I'm just going along with you guys. What's 96 and 168? $264. Okay. Have we made a mistake anywhere? Okay. Now what? Divide both sides by? Okay. What is it? Okay. If we did this. Yes. Either way, whichever way you guys are comfortable. But if you have questions about something, if you guys are not understanding why we're doing something, or ask, hey, can I do it another way? I saw it another way. You have to ask me. Don't just blindly follow along with everything I write down and just be like, oh no, I don't know. Ask me. I might make a mistake. You might make a mistake. We might discover a different way that someone can look at something. But you guys need to be active participants. When you're doing this, is it helpful to have your phone next to you and be keying everything into your phone instead of using your brain? No. Because do you have your calculators on a test or a quiz? No. So some of you are real quick to be like, yeah, it's this, it's this, it's this. And then all of a sudden your quiz comes and you're like, whoa, the numbers are bigger than 6 and 4. I don't know what to do. All right, so let's look at 14. I look at 14 and I think, uh-oh. Why do I think, uh-oh? There's a decimal and a fraction. So what do we do? Say it again. We could do that. What could you turn the decimal into? 1 over 4. How come you wouldn't change the fraction into a decimal? It's a repeating. Good. I don't want you guys saying, oh, well, 2/3, it's the same as 0.666. Oh, I'm going to put a line over it. Right? Do we do that anymore, guys? No. So we're going to have to think a little bit. All right? Where's my eraser? Forgot for a second how to erase. Okay, so I'm going to rewrite this as 2x over 3. What am I rewriting 0.25 as? 1/4 x. Are you guys okay with me writing it like this? No. Don't say yes. Am I okay like that? Huh? What's in front? If you're not comfortable with it, then do this. Right? You guys agree? Okay. So equals x plus 2. Now what do I have to do? A common denominator. What's my common denominator going to be between 3 and 4? 12. So if I multiply the bottom here by 4, then I multiply the top by 4, yeah? So 8x. If I multiply the bottom here by 3, then I multiply the top by 3, and I get... Guys? Okay. Can I put x plus 2 over 1? Yep. Now what? In a second. What can we do? You're okay. You can add like terms. So 11x over 12 equals x plus 2 over 1. You guys with me? Okay, so when I cross multiply, I get 12 times x plus 2, right? Equals 11x times 1, which is 11x. All right, then I already heard Mia. She's like, oh, can't you just distribute and say 12x plus 24? You absolutely can. Now, in this case, does it make sense to do what I like to do and move letters to the left and numbers to the right? No. But could I? Yes, I could move 11x over and then the 24 over, which is what I'm going to do because it just makes me feel better in life. So minus 11x from both sides. You guys agree? And then I'm going to subtract 24. What am I subtracting 24 from? 0. Okay, you don't have to write it or anything like that. So you end up here with x equals what? Negative 24. Did you have to do it that way? No. I just feel better when the variable is on the left-hand side of the equal sign. It's how my brain is trained. Holy moly, what's going on in number 15? I hear, oh God. Have you guys ever heard you need to work from the inside out? Anybody ever heard that? Okay, so I'm going to keep 4 just hanging out here, all right? 4 is outside of a bracket. It's not even in a parenthesis. It's a bracket. So I have 2x. What do I do with this negative sign? I'm going to distribute it. So minus 3 plus x plus 5. Then I'm going to close off that bracket. We're working from the inside out. Then I have the rest of my problem. Negative 7x minus 2. Do I have anything on the inside of that bracket that I can combine? The x's. So I have 2x and 1x gives me 3x. I have a negative 3 and a positive 5 gives me plus 2. Perfect. I'm not even worried about moving variables from one side to the other. I'm just trying to get the left-hand side a little more simplified. Now what can I do with that 4? Now we can distribute. 4 times 3 is 12x. 4 times 2 is 8. Whoa, that is not a good-looking 8. Equals negative 7x minus 2. Now what? I'm going to add 7x to both sides. And I'm going to subtract 8 from both sides. You guys agree? Okay, 12x and 7x is 19x. Minus equals what? Negative 10. This looks weird. And then what do I do to both sides? Divide by 19. So I came out with x equals negative 10 over 19. How do we feel about that? How do you guys feel about that? You're just like, whatever. Let's go with it. How do we know if we're correct? We could plug it back in. Are any of you going to do that when you get a fraction like that? Don't tell me no. On the test you will? Okay. Oh, good. So you're just going to hope? Yeah. Coven said he would do it on the test. All right. We're gonna come back to this one at the end, and we'll see if we were right. I'm going to take a picture of it. We'll come back. All right. Paul said that he would plug it into maybe like the third to last step. All right. That's better than not doing it at all. All right, let's look at these last ones, and we're going to come back to that one. What do I do for 16? First thing I should do. We're going to distribute that negative 2. So if I distribute the negative 2, I have negative 2x minus 8 plus 3x equals x minus 8. Agree? Okay, can I combine anything on the left-hand side? Okay, I have a negative 2x and a positive 3x gives me x minus 8 equals x minus 8. Does anybody notice anything right now? It's going to be what? Okay. If you see that here, guys, great. Good for you. If you don't, finish the problem. I want letters on one side and numbers on the other. So I'm going to subtract x from both sides, and I'm going to add 8. Well, on the left-hand side, what's x minus x? 0. What's negative 8 and positive 8? 0. What's negative x and positive x? 0. What's 8 and negative 8? 0. What happens when the left-hand side is equal to the right-hand side? Your variables cancel. All real numbers. Miss Ferry, we say all real numbers? So all real numbers. What does that mean? Explain that to me. All real numbers. Okay, big deal. Tell me. You could be anything. You could put anything in for x and it will satisfy the equation. Good. All right, 17. What shall I do first? Distribute, okay? 3 times 3x is 9x. 3 times negative 1. 3 times negative 1 minus 3, okay? Equals 9x plus 7. All right, I'm going to move letters to one side, numbers to the other. I'm going to go ahead and subtract 9x here. And then I'm going to add 3 here. So I have 0, 0, 0, 10. Huh? 0 equals 10? No solution. Does 0 ever equal 10? No. If you get an untrue statement, guys, no solution. If everything cancels and the left-hand side is the same as right-hand side, all reals. Understand the difference there. All right, I want you guys to do 18. Go. All right. Who cares? Who cares? Who cares? Tell me what to do. Go.
So you distribute negative 6 into 2x, which is 12, negative 12x.
Uh-huh.
And then minus 6.
Good.
And then you do distribute negative 3 to x minus 4, which is negative 3x plus 4.
Perfect.
And then equals negative 15x plus 1.
Does everybody agree so far? All right.
And then you're going to simplify the left equation, and you're going to do minus 12x minus 3x, which is minus 15x.
Perfect.
And then minus 6 plus 12, which is plus 6.
Good.
And then equals 15, negative 15x plus 1.
Okay.
And then you're going to do minus 6 on both sides. And you're also going to do plus 15x on both sides.
Perfect.
Which equals 0 equals negative 5, which is my solution.
How many people agree with Miss Mia? Good job. Be confident in yourself. Very good job. All right, Paul Davies, you want the floor? Okay. Paul, what's your middle name?
Kai.
I won't call you Paul Kai Davies, but I do like Paul Davies.
Why are you calling about?
I have no idea. I have a friend in high school.
I'm not used to it.
I know. It's okay. All right, go.
Okay, so first I distributed one half.
Okay.
3x plus 7.
3x plus 7. Gotcha.
And then on the other side, I distributed the 2 to get 2x plus 6.
Perfect. Whoops. I don't know why I put that. Okay.
And then we can simplify the right side to get 2x plus 7.
What do we notice here?
All same.
It's the same, right? If you get here, I'm fine with all reals. If you want to see it to the end, feel free. Go ahead.
So we get a real number.
Okay, because if we subtract 3x from both sides and subtract 7, what happens? Everything cancels. So we're all reals. Good. But guys, what is the beauty? Before you hit submit on all of the problems that I put on WebAssign, before you turn in your quiz next Thursday, what can you do? Plug it in. Plug it back in. Verify your solution. Know when you turn it in, I got these all right. I'm good. Sound good?
Yeah.
All right, good job, guys.